Hi everyone. In our previous session we have discussed about support vector machines. How the support vector machines classifier finds the maximum margin hyperplane in order to classify my uh, data into two categories. Okay. So today we are going to discuss about the nonlinear problems about how support vector machines, which is a linear classifier, can be used for nonlinear problems as well. Now let me explain you. Now, this is a non-linear classification problem wherein we need to classify into red and blue dots. Now, suppose I try to make a single line and do the classification, it will not give me a good accuracy, right? The accuracy is really bad. So, no single line can classify my points into red and blue. Rather, we'll need a circle to classify into red and blue, two separate clusters, right? Now, how SVM can be used to handle this kind of a non-linear problem is using a kernel trick. The kernel trick will transform my data into a higher dimensional feature space. Okay, so this is the two-dimensional feature space, right? X1 and X2, and we are going to transform this original feature space into a higher dimensional feature space, that is three-dimensional feature space now. X1, X2 and X3. And now we'll push the red dots towards the left side and the blue dots towards the right side. Once this is done, we can use a two-dimensional hyperplane to separate these dots into clear clusters. So we'll find the maximum margin hyperplane which separates the two separates into two different categories. Now this is done using the kernel function I told you. The kernel function makes easier for us to handle the curse of dimensionality despite increasing the number of dimensions. Okay, the problem with the linear classification setup is that the need to calculate the dot products of the huge number of vectors while finding the distance from the hyperplane. On the other hand, kernel function operates on only 2 points. So we need not take the dot product of vectors and hence making it computationally efficient. Let me explain you the kernel function now. So this is my kernel function. E to the power minus of x minus landmark. So landmark is the 0, 0, this point. Okay. Divided by 2 standard deviations whole square, the standard deviation of my Gaussian function. Okay. So as the distance from the landmark, that is point 0, 0 decreases, the kernel function tends to 1. Can we notice this? If the distance is very, very small, then it tends to 0 and the kernel function tends to go to 1. And as the distance increases, suppose this x is very far away at this point, the distance will be very high and hence e to the power minus of a very high value, which will tend to 0. So all the points on this blue region are classified as 0 and all the points in between this the normal curve are the Gaussian curve are classified as 1. Okay. Now that's what again we are iterating in this slide, the same thing we are iterating in this slide also, that all the points that are inside the Gaussian curve are classified as 1 or green and all the points on the outside in the purple region are classified as 0 or red. Okay. Now let's explain you the relevance of this denominator in our term, in our expression. The standard deviation whole square. What is the relevance of this standard deviation? The higher the standard deviation, guys, the higher is the curve, this curve. Intuitively also it makes a lot of sense. A higher the standard deviation, higher is the circumference of my Gaussian curve. And this means more points will be classified as 1 or green. Okay, and less points will be classified as red or 0. And a lower standard deviation will mean that the circumference of my Gaussian curve is small, and hence less number of points will be classified as green and more number of points will be classified as red. Okay, so let's have a look at this diagram. Over here, if I want to classify, we'll convert it into a three-dimensional feature space, and then green is pushed towards the right side and red is pushed towards the left side. But can a single Gaussian function be used over here to make the decision, to make the classification decision? No, we'll be using the two. So these are the two kernel functions that we'll be using. It will be classified as green when kernel with landmark 1 plus kernel function with landmark 2 is greater than 0. Okay, so it will be classified as green or 1, and wherever it is equal to 0 it will be classified as red. Okay, so what we notice over here is that in an n-dimensional feature space also, we'll transform it into an n+1 dimensional feature space, and then we can find an n-dimensional linear hyperplane using the kernel trick, which might be non-linear in the original feature space. Thus, kernel trick helps us in handling the curse of dimensionality really well by making our computations efficient without losing the information conveyed by the dimensions. Thank you guys. I hope you've enjoyed the video, and please like my video and share my video, and please subscribe to the channel. Thank you. Bye. Questions welcomed.